Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 28 and today we are again going to solve a problem based on backtracking and the level of this question is going to be medium. The name of this question is permutations. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So here we are on LeetCode and the question statement says that given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. So question is pretty short and straightforward. Question is saying that, hey, I have given you one array named as nums and that nums array includes only distinct integers. Now you have to return all the possible permutations and you can return your answer in any specific order. So now let's look at some of the sample test cases. So if we see example 1, then here inside this nums array, we are having 3 elements, 1, 2 and 3. And we can clearly see that we are only having distinct integers inside this nums array. Okay. And the output will be all the possible permutations of our nums array. Similarly, we have some more examples here. So firstly, let's try to analyze the question by taking some examples and then we will think of how we can solve this. Let's take this particular nums array to understand how we are going to solve this problem. So in the question, it was clearly mentioned that we have to generate all the possible permutations. So very firstly, we should know what is the meaning of a permutation. So permutation is nothing but the arrangement of the elements, right? For example, if this is our nums array, so here you can clearly see that in total, we are having 3 number of elements. Okay. So now we have to arrange these 3 numbers in all the possible combinations, right? So how we can do that? See, at this particular first place, what all options do I have? I can place either 1, I can place either 2, or I can place either 3, right? For this first position, I have 3 options. So let's say that in this first position, I will write 3, right? Let's say that I will place this 3 at the first position, right? So now this 3 has gone, right? I have already placed it, right? So now for this particular second place, how many options do I have? So at this second place, either I can place 2 or I can place 1, right? So for this second place, I am having 2 options, right? So let's say that I have decided that I will place 1 here, right? So I will place 1 here, correct? So now if we talk about what all options do I have to fill this place 3. So here you can clearly see that I have already placed 3. I have already placed 1. So for this last place, I am having only one option, which is 2, right? So here I will place 2. So now you can clearly see that this 3, 1, 2 is a possible permutation of this nums array. Okay. And if we talk about what are the number of possible permutations we can have. So here we are having 3 number of elements, right? In this nums array, we are having 3 number of elements. So if we try to find out what are the possible number of permutations. So see, when we are standing here at this first place, we had 3 options, right? Either I can place 1 here, either I can place 2 here, or either I can place 3 here. So here you can say that we had 3 number of options, right? And when I was standing here at place 2, then I had 2 options. Either I can place 1 or either I can place 2. So here you can see that we had 2 options. And when I was standing here at the last place, then I had only 1 element remaining, right? So for this third place, I had only 1 option, right? So if I multiply this all 3, 2 and 1, then I'll get 6. And this 6 is nothing but the number of all possible permutations I can have for this particular nums array. This 6 is nothing but a 3 factorial, right? So we can say that if the size of our nums array is equal to n, then the number of possible permutations will be n factorial, right? So I hope you have understood this. So now let's try to write all the possible permutations of this nums array. Okay, so what will be our first permutation? My first permutation will be 1, 2 and 3, right? You can see that this is also a valid permutation, right? Now, in order to generate my second or in order to generate my next permutation, what I can do is I can just swap this 1 and 2, right? So if I will swap them, then my permutation will have 2, 1 and 3, okay? So you can say that this is also a valid permutation, right? Now, in order to generate my next permutation, what I can do is I can just swap this 1 and 3. So if I decide that I will swap this 1 and 3, then my next permutation will consist of 2, 3 and 1. And this is also a valid permutation. Okay, so now in order to generate my fourth permutation, what I can do is at this 1, 2 and 3, I can just swap this 1 and 3, right? So if I have decided that I will swap this 1 and 3, then my fourth permutation will have 3, 2 and 1, right? And you can clearly see that this is also a valid permutation, right? Similarly, to generate my next permutation, what I can do is I can just swap this 2 and 1, right? So if I have decided that I will swap them, then my next permutation will have 3, 1 and 2, correct? Similarly, in order to generate my next permutation, I can swap this 1 and 3. So if I'll swap them, then my next permutation will have 1, 3 and 2. So here you can see that we are having 6 permutations, and for this particular nums array where the size of this nums is equal to 3 and 3 factorial is equal to 6, so these are the 6 possible permutations for this nums array. Okay, one thing which you need to observe is in order to generate permutation, what we are doing, we are just swapping the elements. Okay, so if we are successfully able to swap all the combination of our elements, then we will definitely find out all the possible permutations, right? So keep this in your mind that we are going to swap the elements in order to find out our permutations. So let's consider this particular nums array to understand how we are going to solve this problem. One thing which we surely know that we need to swap different elements to find our permutation. Okay, we know that we are having 3 number of elements. Okay, for this first place, what I can do, either I can place 1 here, either I can place 2 here, or either I can place 3 here. And how I can do this with code, I can swap this 1 with this 2, I can swap this 1 with this 3, or I can swap this 1 with 1 itself, right? Then I will have all the 3 different options, right? So let's say that initially I'm having one variable I which is pointing at index number 0, right? So if I decide that I will swap this 1 with 1 itself, right, then my permutation will remain same. I'll have 1, 2 and 3, right? Similarly, if I decide that I will swap this 1 with 2, then my permutation will become 2, 1 and 3, right? Similarly, if I decide that I will swap this 1 with 3, then my permutation will have 3, 2 and 1. Okay, so what I have done till now is for this first place, I have tried to place 1, I have tried to place 2, and I have also tried to place 3 here, right? So now we will try for this second place. So the index for this first place is 0, index for the second place is 1, and index for this third place is 2. Okay, so initially my eye was pointing here at index number 0, right? It means that for the first place, I have tried all the 3 permutations. Okay, so now I'll move to the next place, which is my next index, which is index number 1, right? Therefore, now my eye will point here at index number 1, right? Here as well, my eye will point here at index number 1. Here as well, my eye will point here at index number 1, right? And let me just write the other indexes as well. So now if I try this particular permutation, then right now I'm standing here at index number 2. Okay, so what are the different swapping options do I have? Either I can swap this 2 with 2 itself, or either I can swap this 2 with 3, right? So at this particular place, I'm having 2 options, right? So we will explore all the 2 options, right? So let's say that I have decided that I will swap this 2 with 2 itself. Then my permutation will be 1, 2 and 3, right? Similarly, if I decide that I will swap this 2 with 3, then my permutation will become 1, 3 and 2. Okay, and if I just try to write down the indexes, then my indexes will be 0, 1 and 2 and 0, 1 and 2 here as well. So previously my eye was pointing here at index number 1, right? So at this particular function call or at this particular permutation, my eye will point here at index 2, and at this particular permutation as well, my eye will point here at index number 2. Why? Because for this particular index number 1, I have tried the 2 possible permutations. Okay, so now I will try the possible permutations for this index number 2, right? So at this particular index number 2, what are the different options I have? See, after this element 3, I don't have any other options, right? I don't have any other element, right? So now what I'll do is I will swap this 3 with 3 itself, right? So now my permutation will become 1, 2 and 3. Okay, and my eye will point here, right? My eye will go out of bound, right? And whenever my I have gone out of bound, I can say that I don't have any other remaining elements to swap, right? Therefore, I can clearly say that this is a valid permutation which I can have. Okay. So now what I'll do is I will just store this 1, 2, and 3 inside a different data structure, right? Or inside a vector of vector, right? Because we need to return our answer in a vector of int, right? So let's say that I have stored this inside a vector of vector, right? So now my I have gone out of bound. So now what I'll do, I'll move back to my previous function call. Okay. So right now I'm standing here at this particular function call, and here my I was pointing at index number 2, and I had only one option, and that option was to swap this 3 with 3 itself, and I have explored that option. Okay. So now what I'll do, I'll move back to my previous function call. Okay. So now I'm standing here at this particular function call. Okay. So here my I was pointing at index number 1, and I had one option. That option was to swap this 2 with 2 itself, and I have explored that option. So now what I'll do, I'll go to the other function call where I will swap this 2 with 3. Okay. So right now I'm standing here at this particular function call. Okay. And my I is pointing at index number 2, right? So when my I is pointing here at index number 2, and I don't have any other element after this particular index, then I have only one option. And that option is to swap this 2 with 2 itself. Okay. So if I swap this 2 with 2 itself, then my permutation will have 1, 3, and 2, and my I will go out of bound. Okay. And again, whenever my I is going out of bound, we can say that we don't have any other elements to swap. That means this is the possible permutation I can have. Okay. After doing this, what I'll do, I'll move back to my previous function call, right? So now I am standing here at this particular function call, right? So at this particular function call, I had only one option, and that option was to swap this 2 with 2 itself. And I have already tried that option. So now what I'll do, I'll move back to my previous function call, right? I will move back to my previous function call, right? So again, I'm standing here at this particular function call. And at this particular function call, I had two options. The very first one was to swap this 2 with 2 itself, and I have tried that path. The second option was to swap this 2 with 3, and I have also tried that particular path, right? So now what I'll do, I'll move back to my previous function call. Okay. So now I am standing here at this particular function call. So right now I'm standing here at this particular function call. Okay. And I have already tried this particular path. So now I'll come at this particular function call. Okay. So now I'm standing here at this particular function call where my I is pointing at index number 1. Okay. So this is the element 1, right? This is the element 1 which is present at this particular index. So now what are the options I have? I can either swap this 1 with 1 itself, or I can swap this 1 with 3. Okay. So for that, what we will do, we will make two different function calls. Okay. So if I have decided that I will swap this 1 with 1 itself, then my permutation will have 2, 1, and 3. And if I decide that I will swap this 1 with 3, then my permutation will have 2, 3, and 1. Okay. So let's consider this particular permutation. And if I try to write down the indexes, then the indexes will be 0, 1, and 2. And now my I will point here at index number 2. Okay. And after this index, we do not have any other element, right? So now I am left with only one option. And that option is to swap this 3 with 3 itself. So if I do so, then my permutation will have 2, 1, and 3. And my I will go out of bound. Okay. So now my I will point here, right? It is out of bound. So whenever my I is going out of bound, it means that I don't have any other elements remaining to swap, right? And when I don't have any other element to swap, it means that this is a possible permutation, right? Which I can have. Okay. So I'll just store this permutation in a different data structure. And after storing it, what I'll do, I'll move back to my previous function call. Okay. So now again, I am standing here at this particular function call. And here at this function call, I had only one option. And that option was to swap this 3 with 3 itself. And I have tried that option. So now what I'll do, I'll move back to my previous function, right? And again, I'm standing here at this particular function call where my I was pointing at index number 1. So here I had two options. The very first option was to swap the 1 with 1 itself. And I have already tried that path. So now what I'll do, I'll try to swap this 1 with 3. Okay. So therefore, I will come here at this particular function call. So if I try to write down the indexes, then my indexes will be 0, 1, and 2. And now my I will point here at index 2, right? And after this index 2, I don't have any other element. What does it mean? It means that I have only one option. And that option is to swap this 1 with 1 itself, right? And if I do so, then my permutation will have 2, 3 and 1, and now my I will go out of bound. Okay, so whenever my I is going out of bound, it means that we are not having any other element to swap, right? And if we don't have any other element to swap, it means that this is a valid permutation I can have. Okay, so I'll just store it inside my answer or in a bigger data structure, and then I will return back to my function call. Okay, so now again I'm standing here at this particular function call, and here I had only one option, and that option was to swap this 1 with 1 itself, and I have already tried that option. So now what I'll do, I'll move back to my previous function. Okay, I'll move back to my previous function. So now I'm standing here at this particular function call. Here I had two options. The very first one was to swap the 1 with 1 itself. The second one was to swap 1 with 3 itself. And I have tried both of them. So now what I'll do, I will move back to my previous function call. Okay, so from here I will return back to my previous function call. So again I'm standing here at this particular function call. Okay, and I have tried to swap this 1 with 1 itself. I have also tried to swap this 1 with 2. So now I will try to swap 1 with 3. Okay, therefore I will come here at this particular function call. Okay, so here my I is pointing at index number 1. So again I'm having two options. The very first option is to swap this 2 with 2 itself, and the second option is to swap this 2 with 1. Okay, so let's say that I have decided that I will swap this 2 with 2 itself. Then my permutation will have 3, 2 and 1. And if I decide that I will swap this 2 with 1, then my permutation will have 3, 1 and 2. Okay, so let's say that I'm standing here at this particular function call, and if I try to write down the indexes, then this will be my indexes, and my I will point here at index number 2. Okay, after this index number 2, we are not having any other index or any other element. It means that at this particular index, I have only one option, and that option is to swap this 1 with 1 itself, right? So if I decide that I will swap this 1 with 1 itself, then my permutation will have 3, 2 and 1, and now my I will move out of bound. Okay, whenever my I is going out of bound, it means that I do not have any other element to swap. If I don't have any other element to swap, it means that this is a possible permutation. So I'll just store it inside a bigger data structure. Okay, and after doing this, what I'll do, I will move back to my previous function call. Okay, I'll move back to my previous function call. So now I am standing here at this particular function call. Okay, and here my I was pointing at index number 2. Okay, so here I had only one option, and that option was to swap the 1 with 1 itself, and I have already tried that option. So now what I'll do, I'll move back to my previous function call. Okay, so right now I'm standing here at this particular function call. I have tried to swap this 2 with 2 itself, right? So now what I'll do, I'll try to swap this 2 with 1. Okay, so therefore I will come here at this particular function call, and if I try to write down my indexes, then these are my indexes, and my I variable will point here at index number 2. Okay, and after this index, we do not have any other indexes, or we do not have any other element. So here I have only one option, and that option is to swap this 2 with 2 itself. And if I do so, then my permutation will have 3, 1 and 2, and now my I will go out of bound. Whenever my I is going out of bound, it means that we have got our valid permutation. Okay, so now what I'll do, I'll just store it inside one bigger data structure, and after doing that, what I'll do, I'll move back to my previous function call. Okay, so right now I am again standing here at this particular function call. Here I had only one option, and that option was to swap 2 with 2 itself. I have already done it. Okay, so now what I'll do, I'll move back to my previous function. So now I am standing at this particular function call. Here my I was pointing at index number 1. That means that I had two options. The very first option was to swap this 2 with 2 itself. The second option was to swap this 2 with 1 itself, right? And I have tried both the options. So now what I'll do, I will move back to my previous function call. Okay, so now I'm again standing here at this particular function call. Okay, and I have tried all the possible swappings, right? So now what I'll do, I'll just return my answer, and inside my answer, I will have all these 6 permutations. Okay, so this was the approach. I hope that you have understood this. Just remember one thing, that we are just trying to swap elements, right, with the other elements which is possible, right? So this is the only intuition which we have used in this all approach. Okay, but there is one more thing which I need to explain you before writing the code. So we know that we are swapping different elements to generate our permutation. Okay, so let's say that if I decide that I will swap this 1 with 1 itself, right, then I should get this permutation, right? And if I decide that I will swap this one with 2, then my permutation should look like this, correct? Similarly, if I decide that I will swap this one with 3, then my permutation should look like this. Okay, I hope you are getting it. And from this particular function call, we will try other permutations. From here as well, we will try different permutations. From this particular function call as well, we will try different permutations, correct? But one thing which you need to observe is, when I was standing here at this particular function call, then inside my nums array, I had 1, 2, and 3. But when I went on to this particular function call, then I swapped this 1 and 2, right? I swapped 1 and 2, and remember that I'm doing swapping inside my nums array. Okay, so when I am standing here at this particular function call, then inside my nums array, I have done a swapping, right? So now inside my nums array, I will have 2 and 1, 2, 1 and 3, right? But when I'm going back from this function call to this particular function call, then inside my nums array, I should have 1, 2, and 3, so that I can swap this 1 with this 3, correct? But right now inside my nums array, I have 2, 1, and 3, right? So if I'll swap these two elements, then I would get 3, 1, and 2, right? But this is not what should I get, right? I should get 3, 2, and 1. In order to get this, what I have to do is, I have to just roll back to my previous state, right? I should get the elements as 1, 2, and 3 inside my nums array. For that, what I can do is, I can swap these two elements again. So if I swap them again, then inside my nums array, I'll have 1, 2, and 3. And this is indeed what I want, right? This is indeed what I want. So from here, I can easily swap this 1 and 3, and then I will come here at this particular function call, right? So this is something which is very important to understand. That is, whenever we are moving back from a function call, we have to swap the elements again in order to get the previous state of our nums array, right? I hope that you are getting this. Let's say that we are having a function, and inside this function, we are receiving our nums array, right? And we have to return all the possible combinations. So during our dry run, I have explained you that we will have one variable named as answer. You can name it something else as well. But this answer variable is going to be a vector of int. Okay, and we need to return this answer at the end. Therefore, what we will do, we will make a 2D vector, right? We will make a vector of int, and I will name it as answer, right? And at the end, I will return my answer, correct? But we know that we need to make different calls to swap different elements, right? So for that, what I can do is, I can make a different function named as solve, right? And I will call this function inside this main function, right? And inside this solve function, I will start doing swapping from index number 0. Therefore, here I will send index 0, and here I will send my answer as well. Okay, so now we just need to write the code for this solve function. Okay, so we know that our solve function is not going to return us anything. Okay, therefore here I can write void solve, and here I am firstly I am getting my index, right? You can call it as index, and the second thing I'm getting is my answer variable. Okay, and apart from this, do I need something else as well? Yes, I would also need my nums array, right? So let's say that I'm sending 0, my answer, as well as my nums array. Okay, and here inside this solve function, I will also receive my nums array. Okay, so very firstly here we will write our base case, that if at any point my index is greater than or equal to nums dot size, then what we need to do, we need to store our answer inside this particular answer data structure, and then we will return back. Okay, so here I can just simply write answer dot push back my nums, right? Because remember that we are swapping elements inside our nums array, right? Therefore, if index is out of bound, then I can just store whatever is present inside my nums array into my answer, right? And after doing this, I will return back. Okay, so let's say that this is my nums array, right? And initially my index is pointing here at index number 0, correct? So I know that firstly I need to swap this 1 with 1 itself, then I need to swap this 1 with 2, then I need to swap this 1 with 3, correct? So for that, what I can do is I can write a for loop, right? Here I will write int I is equal to my index, right? I is equal to my index, and then I will go until it is lesser than n, and then we will do some I plus plus. Okay? And here what I can do is, here I can directly write swap nums of I and nums of index. Okay, so if you are not getting this, why we are doing it, let me just give you one example. Okay, so see, initially my index is pointing at index number 0, right? Index variable is pointing at index 0, and initially the value of I will also be equal to 0, because this I is starting from my index and it is going up to it is lesser than n. Okay, so initially the value of index is also 0 and the value of I is also 0. So this particular swap statement, what it will do is it will swap this 1 with 1 itself, right? Then after one iteration, the value of I will become 1, right? And my index is pointing still at 0, right? So now my I is pointing here at index number 1. So now what we will do, we will swap the elements which are present at index 0 and index 1. Simply, it means that we will swap this 1 and 2, correct? Similarly, in the third operation, the value of I will be equal to 2, right? And the value of index is still equal to 0. So now what we will do, we will swap the elements which are present at index number 0 and index number 2, or you can say that we will swap 1 and 3. Okay, so this is what we are going to do. And whenever we are doing a swap, we need to call the function for the next index. Okay, so here I will just write index plus 1, and here I will pass my answer variable and my nums as well, right? And after coming back from this particular function call, I need to again swap it, right? So that I can roll back to my previous state of nums array, right? For that, here I can directly write swap nums of I and nums of index. Okay, so this is going to be our code. It is pretty short and pretty easy. So I hope that you have understood this. So now if we talk about the time complexity, then if the number of elements are equal to n, then the time complexity is going to be n factorial. Why it is going to be n factorial? Because the number of permutations for n distinct elements will be equal to n factorial. Okay, and second thing is, inside our base case, we are storing all the elements from our nums array inside into our answer. Okay, and what is going to be the size of our nums array? It is n, right? So therefore the time complexity will be n factorial into n, right? This extra n is due to this particular line of code, right? Answer dot pushback nums, right? So I hope that you have understood the time complexity. The reason why I have written this n factorial is the total number of permutations are going to be n factorial, right? Therefore this solve function will be called n factorial number of times. So now if we talk about the space complexity, then we are using one answer variable, right? We are using one answer variable, and inside this answer variable, we are storing all the number of permutations, right? So how many number of permutations I will have? The number of permutations will be n factorial, right? And what is the size of one permutation? So the size of one permutation is going to be n, right? So n factorial into n is nothing but the size of my answer variable. We are calling this solve function again and again with the help of recursion, right? And if we are using recursion, then recursion will definitely take some function call stack, right? And what will be the total space taken by a recursion? It will be nothing but n, right? Because the maximum depth of our recursion tree will be equal to n. Okay, so these are the time and space complexities. I hope that you have understood the code and the complexities as well. So now without wasting much time, let's directly code it up on LeetCode. So here we are on LeetCode, and here you can clearly see that we need to return a vector of integers. Okay, therefore what I can do is I can create a vector of integers, and let me name it as answer. You can name it something else as well, and at the end we will return our answer, right? Apart from this, let me also store the size of my nums array, right? And then I will call my solve function with the index number 0, with the size of my nums array, with my nums array, and with my answer, right? So it is ans answer. So now we just need to write the code for this solve function, and that is going to be very easy for us. Okay, we know that our solve function is not going to return us anything, therefore I can write void solve, and here I will receive my index, here I will receive my n, and I will also receive my nums array. Okay. Apart from this, I will also receive my answer variable. Here we have received this answer variable by reference. And by the way, this is very important because at the end inside this particular function, we are returning our answer. Okay. So therefore it is very important to receive it by reference. And here I can just simply write my base case that if my index is greater than or equal to n, then I will put my current permutation inside my answer variable. So here I will write answer.pushback nums, and after that I will return back. Okay. Now apart from this, here I will write a for loop. Here I'll write int I is equal to index. Correct. I should be lesser than n, and here I will write I plus. Okay. So very firstly, I will swap nums of I and nums of index. Correct. Apart from this, I'll call the solve function with the next index, which is index plus 1. And I'll send the other parameters as well, such as n, nums, and answer. And after coming back, I will again swap, right? So here I'll again write swap nums of I and nums of index. So this is our code. I hope you have understood it. Now let me run this. So here you can clearly see that all the 3 sample test cases are running fine. So now let me submit this. So here you can clearly see that this particular code is accepted. So I hope this video was helpful to you. If it was, then make sure that you like to this video. Don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel as well. We will meet again tomorrow with a new question.